Let's just jump right into it for cosine, now that you've seen how the sine curve works. Again, what I want you to notice about cosine is that we are going to measure the pink region, right, the x value, because we learned that cosine is in charge of x over r. So you'll notice that as in this region, it starts at 1 and it decreases to 0. So right now it's at its maximum value at 1, and then it's getting smaller and smaller and smaller as the angle increases. So we see it different than sine because it starts at that 1 spot, and then at the 90 we are now at 0. Now cosine will begin to be negative now because that would be negative x in that region, and then it goes all the way to negative 1. So we see it grow to negative 1. Now we begin increasing, it comes back closer to our 0 value, and then finally in that last quadrant it is going to increase in a positive way. So we see what it did for us is it went all the way through that cycle from 1, and then it went down to 0, and then down to negative 1, and then up to 0 again, and then finally repeated its last spot. And so the cosine curve then follows this as its shape. Now very similar to sine, but it has different key points. It is at 0, it is at its maximum 1. At 90, or pi over 2, it is at 0. At 180, or pi, we are at negative 1. At 270, or 3 pi over 2, we are at 0, and then we return back here. It works the same as sine, in that it is cyclic. It repeats itself over and over, but its cycle or period looks like this as its shape. So let's just summarize those key values for you. So these are known as the quadrantal values for cosine. It is at 1 at its maximum. As we decrease to 90, or pi over 2, we come to 0. Then at 180, it is at its minimum of negative 1. At 270, or 3 pi over 2, we return to 0, and then finally return back to 1. These are different than sine, but are important for you to know those values as well.